This is a scrap PCB from an old, I think it's a VCR. It's got a large VFD here which I'm going to try and use or have a go at driving at the very least. And underneath is this chip here, which is the driver chip for the VFD. And I found out that this is actually a 6502 processor in a 64-pin package. It's a Mitsubishi MELP processor. Now this one's mask ROM programmed, so at the moment, as it is on this PCB, you can't really do a lot with it. But I've got the data sheet and found out that there's a pin that you can use, and if you put the correct voltage on there, this starts to spit out address and data buses and some control lines, so you can actually put an external ROM and RAM on it. So I'm going to desolder it and scrap the rest of the board and see whether I can do something interesting with it. So hopefully this qualifies as interesting. I've made up a couple of PCBs. This one here has got a full keypad of 36 keys and a reset button. They're Cherry MX type keys. They're quite nice to use. It's got the VFD from the VCR and the MELP from the VCR, which is here. It's also got an OLED display. Now that's attached. This is the same board, but obviously I've only got one VFD and one MELP, although there is another one there. I'll get onto that later. It's got two drivers here for the VFD. It's got an ARM processor, OLED display attached to the ARM, and the keyboard here, which is only partly populated on this one, didn't buy enough keys for two. The keyboard is attached to the ARM processor as well. Optionally, all these jumpers allow you to attach the VFD driver and the keyboard to the MELP, so you could run with the MELP actually reading the keys and driving the display, but as it's set up at the moment, both of them have the ARM driving the VFD and scanning the keyboard. Now there's no, well, there is some ROM on here because these are mask ROMmed processor chips, but there's no ROM external because I'm going to be driving these in microprocessor mode. There's no ROM or RAM external, and that's emulated by the ARM chip here. It's quite a powerful STM32H742, which has got, I think, 1 or 2 megabytes of flash and coming on for a megabyte of RAM, but I think only about 300k is going to be usable for what I need it for. There's also SD card reader here, so you've got some storage if you want to load and save programs for either the ARM or the MELP actually. So you can use this as just a sort of microprocessor trainer for the MELP, so you can interrogate the address and data buses, watch it run programs and so on, load programs into the processor using the ARM. It's a 6502, so quite standard, and you could run it without the VFD, so that's what the OLED display is there for. The OLED display is for the boards that don't have a VFD on there like this one, because I only have one of those. But it being a plug-in daughter board, you could put any other VFDs that you wanted to try out on there. So it's a VFD testing board, so I can just make up a little perf board adapter and plug in hopefully any VFD that I feel like running on it. So you can use it as a 6502 trainer, sort of single board computer, for investigating the instruction set and the registers of this particular chip, because this is sort of microcontroller, not a microprocessor, so it's got ports and timers and all sorts of things in there. But you could also use it, if you didn't have a MELP, or you didn't want to use the MELP, you could use it as an ARM trainer, so you could actually investigate, using the OLED display on the keyboard, you could investigate what's going on inside the ARM chip, and there don't seem to be a lot of those about. There's quite a lot of 8-bit ones, but not a lot that let you fiddle around at a low level with the ARM chip. I know it's a very complicated chip, and you'd really probably want to program it in in something like C rather than assembler, but I mean the assembler's there. You can program it in assembly language if you want to. So let's start this one up. They're the same. The MELP on here is slightly different. This is a 50959 instead of a 50957 that came out of the VCR. I managed to find these on eBay. There was a batch of 6, so I've got some more, which is 1 for each of the 5 PCBs that I got from my supplier. So let's start it up. There's a little DC-DC converter here to drive the high voltage part of the chip. So that's not actually readable. Let's stick something under there, see if we can see the display. Let's turn the lights out. There you go, that's better. So what that's displaying at the moment is actually the data bus for the MELP and the address bus here. So if I single step this, you can see that things are changing, and at the moment it's in its reset startup sequence. So there's basically, I think, random stuff going on there. I think this is the address of the previous instructions that were running in this MELP, and obviously it's just been powered up, so it's going to be basically random, I think. Here we go. So now this is reading FFFE and 34. Now 34 is the low part of the reset vector for the 6502, so it'll read that in. Then it will go to FFFF, which is the high byte of the reset vector, 1, 2, so 1, 2, 3, 4. It'll read that in, and then it will start fetching data from 1, 2, 3, 4, and that's A9, which is a load accumulator with 2, and that's the processor mode. So there's a register in here which lets you set the processor mode for the MELP, so you can run it in microprocessor mode. There's an expander mode and a single chip mode. So when it powers up, as it's currently configured, it powers up in microprocessor mode so that I can access all the buses. I was hoping to be able to switch it into single chip mode and read out the ROM, but that doesn't seem to be possible. I haven't managed to do that at the moment, so I think maybe there's protection there. You have to toggle a pin, and then the bus changes into a multiplex bus if you're in memory expanding mode. And the ROM should be accessible, but I can't get to it. So unfortunately, I don't think I'll be able to read the ROMs out, but doesn't really matter. That was just one of the things I wanted to try with it. So now we're at 1, 2, 3, 5, and we're stepping through this program. So that's going to read the instructions out of the flash, which is actually the flash of the ARM chip, and then it's a small program which just, when it gets round to it, will write the contents of a memory location. It reads all the memory locations from FFF down and writes them to 2000. So 2000 will appear as an address with the data that it's read. So it's the sort of beginnings of a ROM examination, ROM dumping program. So it's just a very short program that was something to just try out and see whether I could get the thing to single step. So it's single stepping as I press this key here. There's quite a lot of cycles. There's a clock in pin which seems to be about 4 or 8 times the clock out, which means that it requires quite a lot of key presses to actually get the thing to do very much. But you can see there you go, there's 2000 and the data that it's read. So it's FF was read from 2000. I can automatically run the thing, so now it's just stepping on its own and just running that program, and I can speed it up and slow it down by pressing some keys here somewhere. Oh no, that's some test keys that I had. That just turns all the segments on. So we've got the MELP now displaying its address and data bus on the display that it had inside the VCR. So it's sort of back where it started, together with all this extra circuitry to do various bits and bobs. So it's quite fun, and I'm going to use that. I think I will put some ARM examination stuff in there, as well as the 6502. That'd be quite useful sometimes for looking at peripherals and things, maybe. But yeah, so it's a sort of 6502 trainer, VFD tester, ARM trainer, single board computer thing. Right, and there's a reset button there, which resets it. And we're back where we started.